Welcome to today's flip lesson on the area of regular polygons. Let me remind you that you have guided notes you're using and you're taking notes for you. You're not taking them for me. So make sure your notes are good enough that when you go to do the homework, you have quality notes you can refer to and they guide you through what you need to do. Make sure these notes are so strong that when you come back to this in a day or two, when we've moved from the second dimension to the third dimension, you can still figure out how you find the area of regular polygons. And of course, this has to be strong enough that you can come back and use these as a study tool. So we're going to find the area of regular polygons today. And remember, a regular polygon is any polygon in which all the sides are equal and all the angles are equal. Well, there are formulas we could memorize for the area of a regular polygon, but memorizing formulas just means you're going to forget formulas. So let's see if we can logic our way through this by connecting regular polygons to shapes we've mastered. As a matter of fact, you know one of our favorite shapes to go to in this entire year of geometry is a triangle. And if we draw in some of the diagonals of this hexagon, you'll notice we form 6 triangles. As a matter of fact, by using some basic proof, you know that all these sides are equal because it's a regular polygon. You also know, since this is the dead center, that each one of these segments is equal to each other. So by side, 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 we can prove that these 6 triangles inside this regular hexagon, they're all congruent. And we know the area of a triangle is half its base times its height. So in order to find the area of a regular polygon, we can just divide it up into triangles. Let's do a problem. Problem number 1. We have a regular hexagon, and each side is 18 inches. I think it says centimeters on your guided notes, but that's fine. It's not going to change what we do. So the first thing you'll notice we do is we divide this up into 6 congruent triangles. And you know the formula for the area of any triangle is 1/2 the base times the height. Now, in order to find the base and the height, we're going to have to draw in this perpendicular. And as a matter of fact, what I'm going to do is I'm going to draw in this entire right triangle. I call this the fundamental right triangle. Now, what do we know about that right triangle? Well, one thing we know is that this altitude right here, this bisects the base. So the whole triangle is 18 inches, so we know this side right here is 9 inches. What else do we know? Well, what I'd like to find is I'd like to find the measure of this angle right here, this central angle to this hexagon. Remember, this is the center right there. So why don't you take a second, feel free to pause the video, and see if you could figure out what that angle has to be. Well, welcome back. I hope you gave it some thought. Now, we know that this red triangle is called the fundamental right triangle. And we also know that every black triangle in this hexagon has 2 fundamental right triangles in it. So I'm going to argue that there are a total of 12 fundamental right triangles in this entire hexagon. And if you'll notice, as I rotate around that center angle, I've rotated a full 360 degrees. So if I take that 360 degrees and I divide it by 12, and I'm dividing by 12 because I'm arguing that there are 12 of these angles right here that wrap around the center of this triangle, that tells me that each one of those angles would be 30 degrees. So in this particular instance, we know that this is a 30, 60, 90 fundamental right triangle. So I think these fundamental triangles are important enough that what we want to do every time is we want to not only sketch them in our regular polygon, but blow them up over here like this. And so I have this 30, 60, 90 right triangle where this side is 9. Now, hopefully you remember your 30, 60, 90 degree relationships, and this side here would be 9 radical 3. So in every problem you do dealing with a regular hexagon, or I'm sorry, any regular polygon, I'd like to see that fundamental triangle blown up where you've labeled this central angle and then you've labeled the two necessary sides. Now this side here, this hypotenuse, turns out to be 18, but I really don't care, because to find the area of a triangle, I just need the two sides of the right angle, one of them being the base, the other being the height. So how do we find the area of this regular hexagon? Well, the area of this hexagon is going to be 12 of those triangles, 12 of those fundamental right triangles. Again, we know that each black triangle contains two red triangles, and there are 6 black triangles, which gives us 12. So what do I need to see in your homework? Well, what I want to see each and every time is, first of all, the formula. We're going to take 12 of these 1/2 base times height. That's step 1. Show me the formula you're using. Step 2, plug the right numbers in. We have 12 times 1/2 times the base, 9, times the height, 9 radical 3. And step 3, just do the answer and make sure you're labeling it correctly. In this case, it's 841.78 square inches. Let's try another problem. We'll come back to this later on when we meet in person. Let's take a look at problem number 2. Problem number 2 deals with this regular polygon, and I'm counting the sides, and I'm counting 8 sides. So this is a regular octagon. And again, if I divide this up into a series of triangles, I happen to get 8 congruent triangles. And if I go in and I find I drop this perpendicular down, I can make the fundamental right triangle in this picture right here. That's a right triangle. I know that it's going to bisect the base, so I know that this is going to turn out to be 9 inches right there, 9 inches. And what I need to do is I need to find the measure of this central angle. So first of all, let's blow up that picture there. Let's see here. I'm gonna blow this up. So I blew up this fundamental right triangle right here, and I know that that's 9 inches. Now I need to find the angle up here. So the question is, how many of these fundamental right triangles are going to be in this octagon? Well, I hope that you ended up with 16. There are 16 of these little red triangles in this 8-sided octagon. And of course, if we rotate all the way around the center, that's 360. 360 divided by 16 tells me that this angle right here, is 22.5 degrees. Right there, that is, whoa, there's a funny arrow, 22.5 degrees. Now, in order to find the area of this octagon, what I'm going to have to do is take 16 times these yellow triangles. Again, the yellow triangle, this little triangle here, there are 16 of those. Well, I know the base is 9, but the height, what is that height? I'm going to call that height A. Now, before we were dealing with a 30, 60, 90, and that was nice because it was special and we have shortcuts for that. Ooh, but not in this case. Looks like in this case I might have to bring in maybe a story about horses. Which trig function is going to take this 22.5, tie it in with this 9, and this A? Well, I hope you said that that's tangent. So the tangent of 22.5 is equal to the opposite over the adjacent. Now, why don't you take a second and write down, don't do it in your calculator, write down what you think you're going to do to find A. Well, I hope this is what you wrote down. It's part of our shortcut club, and if you're not in it, that's fine. Take it one step at a time. And then pop this into your calculator and keep that number. Notice the ... Keep that number in your calculator. Maybe you should store that because we're going to come and we're going to use that value down here. So this side work should be done. You should be drawing the fundamental right triangle. You should be doing any type of paper and pencil calculation off to the side. There is no reason you should be showing less than I'm showing. So make sure you're writing this down. It's there to help you. So to find the area, we're just going to we have our formula, step 1. We're going to plug our numbers in, 16 times 1/2 times the base of 9 times this 21.72. And then finally, I want to see the answer. Let's take a look at a third type of problem here. We're going to go up into problem 3. Okay, we have a regular triangle. Now, this distance right here, not very useful to us, but we can do our old trick of dropping the altitude down, and then we can say to ourselves, well, one of the things that's going to be really important is finding the measure of this angle right here. Why don't you take a second, pause the video, and see if you can find that angle. Well, welcome back. I hope you realize that there are going to be 6 of these angles right here that completely surround the center of this circle. There is a fundamental right triangle. There are 2 that take up each side, and there are 3 sides, which gives us 6. That means each angle is 60 degrees. So when we look at this fundamental right triangle here, this yellow triangle, we know this distance is 70. We know this angle right there is 60 degrees. That gives us a 30, 60, 90 triangle. We lucked out and got a special right triangle. Now remember, this is my 2s, so this side here should be 6, and then this side right here should be 6 radical 3. We don't need to use trigonometry if it's a special right triangle, and we lucked out getting a special right triangle. So my formula, area, is going to be 6 of these yellow triangles, 6 times a half base times height. Plug the numbers in, do the math. Let's look at another problem. Why don't you try this problem on your own, pause the video, and then I'm going to put up all of my work and you can check and see how you did. So pause the video and come back when you're done drawing in your fundamental right triangle and you've done your side work. Hopefully you went ahead and you drew in this fundamental right triangle here. You did the work and figured out that this central angle, this one right here, is 36 degrees. And hopefully you know that you need to find x. Now choose trigonometry. This is not a special right triangle. Choose the correct trig function, find x. And when you found it, unpause the video. Well, hopefully you chose the tangent function and hopefully you did the math correctly. If you didn't, go back and redo it. Now, let's go down. First thing I want is the general formula. I have 10 of these yellow triangles. I'm going to plug in my base, my height, and then I'm going to round to the nearest hundredth. Let's take a look at our final problem. Let's skip that one, where we want to find the area of this gold region. Now, when you're finding the area of a shaded region, we actually have 4 steps. The first step is I want to see the general formula. So in this case, I'm going to take the area of the hexagon and subtract the area of this blue rectangle. So let's break this up into 2 different shapes and go from there. Why don't you pause the video and see if you can find the area of the hexagon first. And when you've done that, unpause the video. So for the hexagon, hopefully you drew this fundamental right triangle, comes right from the center of the hexagon, perpendicular to a side. Hopefully you came over here and you drew that fundamental right triangle. And I would like you to use your math to figure out that angle there. Again, there are 12 fundamental right triangles in a hexagon. So if I take the entire central angles of 360 and divide it by 12, that tells me that I should get 30 degrees. 30 degrees as the measure of this central angle right there. So it turns out we end up with a 30, 60, 90 triangle. Now, if each side of the hexagon is 12, if each side is 12, that makes this 6, and that makes this 6 radical 3. If I now take a look at that big blue rectangle, in that big blue rectangle, we know that this entire base is 12, because that's a side of the hexagon. And how long is this side? Well, remember 6 radical 3 is this length from the center perpendicular to a side. That's 6 radical 3 right there. So how tall is this entire rectangle? 12 radical 3. 4 things I want to see besides these pictures is 1.